All right, welcome to Electrical Systems. Now we're going to be talking about schematics. Most importantly, documentation in regards to electrical systems, because when it comes down to schematics, you kind of hear that word thrown around a lot, right? And believe it or not, there's actually a difference between schematics, wire diagrams, and control circuits. We're going to go over that real quickly before we dive into specifically what these three are. So when it comes to a schematic, this is basically going to be the overall functionality of that electrical system, right? This is going to show you the pathway when it comes to like your switches, your devices, your motors, your overloads, your fuses, basically of like what goes from where, right? It's like an overview of the system and how it works and how things are connected, right? Whenever you look at schematics, you're looking for like theory of operations and the order in which things are performed or executed. Now, when it comes to wire diagrams, right, this is actually going to be the specifics in the current flow and what it's actually going to be going through when it comes to obviously switches, but also like diodes and resistors. And it's going to be taught in transformers. And basically, the wiring diagram is going to be the direct path of the wires. So wiring diagrams are going to include the specific wires that's associated and the terminal configurations, as well as like your termination points, where your wires are going to, where they're going to be landing, and which wires to check if you wanted to own the continuity between a switch and a motor. Whereas when it comes to a control circuit, that's actually going to be the logic or control of a specific system, device, or process. So again, schematic is going to be the overview of electrical system, right? And this is going to include things like switches and motors and fuses, things of that nature. Now, again, as we talked about though, the schematic is not going to be a direct wire match, right? So this is not always a wire match. So again, that is because when looking at a schematic, it's going to show you where it's going from component to component and not necessarily where those components are located and what wires are specifically connecting between it, right? It's just the overall process that's occurring. So again, not a direct match. If you were to want a direct match, that's going to be your wire diagram, which is going to include specific wire labels and termination points. And this is going to be like a kind of like a map, if you will, of all the wires. And it specifically goes through the current flow, right? So this is more process flow based, right? The overall process, what devices are in what sequence of events. The wire diagram is going to specifically include everywhere that current is flowing through inside the devices and where those wires are landing and what specific wires that you're looking for. Whereas the control circuit is going to be very specific control of a motor or process. Drop my eraser. So again, it could be, it doesn't have to be a motor. It can be a pump. It can be solenoids. It can be several motors. It could be a conveyor. Whatever it is, it's going to specifically control. Now, this is actually directly associated with PLC and ladder logic, because ladder logic and PLC is basically replacing what used to be a manual control circuit. We're used to individually have your relays and stuff like that and specifically control. So, okay, fast forward here. Fast forward backwards here. A control circuit was a low voltage way to control high voltage devices and output. So rather than sit there and physically touch a button or flip a switch with 480 on it, to start that motor, you would touch a 24-volt button that would then actuate a contactor in which would connect the load between your 480s in order to turn that motor on, right? So your control circuit is the controlling mechanism of it. Now we have PLCs and input and output modules, and now we can basically run a lot of these things through there. You're still going to find control circuits within your 24-volt panel, and nowadays your control circuit is what's included within your PLC. PLC is going to be in your control circuit along with some of your devices. But again, there is a difference between these three. Now, typically if you're looking for wire diagrams and schematics, they tend to be in the same place of a manual when you're looking at a system, but there is a difference though. Because again, on a true schematic, you're going to have a hard time finding the actual wires that you're going to be needing, whereas a wire diagram, you're going to find exactly what you need. So it depends on what you're looking for. So now that we've covered the basics when it comes to schematics, now we can go through and we can talk a little bit about the symbols. So as we kind of did earlier in our last video, we talked about series and parallel circuits, and I drew on there things like a battery and things like a lamp and stuff like that, right? Well, it's very important to understand that when you're dealing with circuits, you're going to have a general outline or a key legend that every single schematic and wire diagram is going to follow, right? And so for right now, we're going to start very simple in this video, and we're just going to go over switches. In the next video, we're going to go specifically into devices and relays and fuses and overloads and all that stuff. So again, when it comes to switches, right, it's very important to understand this. You're going to have what's called normally closed and normally open, okay? Now, for a single pull, single toss switch, okay? Very important. Single pull, single toss switch, or SPST, okay? That is going to look like this, okay? So this is a normally closed switch. So basically, in a normal condition, this is going to allow current to flow through. It's going to allow the process to go through until it's actuated. If you were to actuate that switch, then it would open and prevent the flow. So that means a normally open switch is going to be, again, we're going to do single pull, single throw, and we're going to have our switch right here, and we're going to have this normally open. So again, now this is not going to allow current to flow until that switch is activated, and then it will close, and then we're going to have it. Okay, so single pull, single throw. What does that mean, right? So single pull is basically going to be referring to the circuits involved, and single throw is going to be referring to the output. So single pull, one circuit coming in, single throw, one output possibility. So that means there's got to be more, right? Exactly. So now we're going to talk about a double pull, double throw. And so this is actually going to be, as you would imagine, two circuits coming in. And again, it's going to be normally closed, right? And then because it's only or double throw, we're going to have right above it, right here, I'm about to say single throw. And so what a double throw means is now we have two outputs for each circuit. So when you activate a double pull, the switch is going to move together. So circuit A and circuit B, if you hit this one switch, both circuits are going to activate. Now, on a single throw, it's either going to be off or on, right? You're either open or closed. Whereas for this, you could have it execute function 1 or function 2, right? So a double throw is two outputs on that one circuit. A double pull is going to be two circuits for it. So if we were to have a double pull, single throw, right? That's going to be our two circuits right here. They're going to be normally open for this one, and then we're going to have ours right here. So again, single throw. So two pulls, two circuits, and then it's going to be single output. It's either going to be engaged or it's not going to be engaged. And so these are your basic switches when it comes to what you're going to be needing to execute. Now, this is not the same as a push button. When it comes to a push button, that's actually going to look a little bit different. And that's going to look like this. Oh, hold on. Let me keep things the same here. So we're going to make this normally closed so you don't get confused. Okay, this is a normally closed push button. And then this is going to be a normally open push button. So again, when it comes to a push button, you push it, and while you're holding it, it is going to engage. So for this one, it's normally closed. If you push the button, it will open, and it will stay open while you're holding it though. Once you let go of that button, it's going to return to how it was. It's a momentary push button. Okay, so what about a switch that you can actually hold in place? You push it once and it holds in place, right? So that's actually going to be called a latching switch. And that's going to look a little bit different because you're going to have these lines right here. And then it's going to be on right here. That is a normally closed latching switch. And then you're going to have them right here. Okay, and then for normally open, boom, boom, boom. Okay, so you're wondering, why do I see what looks like two circuits here, right? The reason why is because when you're going to be pushing on this button, it is going to hold that contact in place until you push it again. It's going to latch. So if you push this button, it is going to hold that. When you push it again, it is going to release it. So it is still a single function button, but it's going to be holding in place, hence why it's called a latch switch. So I hope this gives you the rough breakdown of not only schematics, but also switches. So again, in the next video, we're going to be breaking down more specifically the different kinds of input and output devices, and we're going to break down the motors and pumps and how those are going to be fitting on the schematics.